So in this question here, we want to work out the probability that this girl who plays tennis, that she can win less than 3 games. Now, what's happening is she's going to play 9 games of tennis, and her previous win rate, to help us with our analysis of what she's going to do in these 9 games, she's had a win rate of 25%. So with that information, we want to calculate the probability she wins less than 3. Now we need to assume each game is independent of each other, and they're all one-off games with no influence on the next game. So we can't assume that she gets tired when she plays the second game and so on. So what's the probability she wins less than 3? So what we're looking for in terms of our distribution, probability x, so less than 3, so we want less than or equal to 2. So that's kind of what we're looking for. So less than 3, 3 is not included, but 2 is. So with that, probably x is less than or equal to 2. What we've got there is a cumulative of x equals 0, 1 and 2. So probability x equals 0 plus probability x equals 1 plus the probability x equals 2. That's kind of what we're looking for with that. Now here, she'll either win or she will lose. Let's assume there's no draws. Each game is independent. There is a number of trials in this case. So this is looking like a binomial distribution question. So with the binomial distribution, so x is distributed b, n, comma, p is our base. So we need to work out what n is and p is. Well, in this case, n would be 9 because there's 9 games. And we need to work out probability. Well, she wins 25% of her games, so let's call that a quarter. So with the binomial distribution as well, it's always handy to work out what the probability of her not winning. So not winning would be 1 minus p, which equals 3/4. So that's our building blocks for this question. So now what I'm going to do is show you how to calculate all of these by hand, and then we'll plug in all the 3 results together and get our cumulative result for x is less than or equal to 2. So for x equals 0, so what we use is probability x equals n, choose x, p to the x, and then 1 minus p to the n minus x. That's our general formula for the binomial distribution in terms of our calculation. So probability x equals 0. So we'll have, in this case, n is 9. So we'll have 9 choose 0. P is a quarter. So it's a quarter to the power of 0. And then 1 minus p, 3/4 to the power of 9. And then with 1 and 2, very similar, but slight change on our numbers. So it'd be 9 choose 1, and then a quarter to the power of 1, and 3/4 to the power of 8. Because this third part here, obviously if she wins no games, she's going to lose 9. So we have to include that into our calculations. There's no point just calculating the ones that she doesn't, or she does. So then probability x equals 2. That would be 9 choose 2, a quarter to the power of 2, and then she's going to lose 7 if she only wins 2. So that's our ways we're going to have to calculate our answer. So probability x equals 0, if you put this one in, so this is what we're interested in here. Let's keep this separate. So put that in your calculator, you get approximately 0.0751. Put this one into your calculator, you'll get approximately 0.2253. I would urge you to check these and leave in a comment below if you think I've made any mistakes. And for x equals 2, 0.3003. So then I'm going to plug those into our calculator, and if you do that, you get approximately 0.600677 and so on. So that is the probability that she wins 2 or less games. Okay, and that would be our answer to our question. Okay,